the result like this on the right side of this slide. We can get a list of possible proteins, and they are ranked according to their percentage of similarity, score value, mesh peptides, and others. So mascot software would help us in identifying individual proteins. These are several parameters that we can change. We can, if we do not want to do any changes, we can use the default parameters related to, as I mentioned just now. And these are uh, um, the values that we can see in our result after using mascot software. Protein score, numbers of peptide mesh, sequence coverage, expected or calculated PI molecular mass, as well as experimental. Okay, so the expected PI value or expected molecular mass from database can be compared with experimental one, experimental pH value and experimental molecular mass, which can be obtained from SDS pH analysis and also mass spectrometric analysis. There are always differences between them, differences between expected and experimental values. These discrepancies, however, still acceptable if they remain in the certain range. For example, 50 kilodalton protein identified in expected value, and 55 kilodalton protein identified in experimental SDS pH. So this small difference is considered acceptable and may not influence our decision in identifying individual proteins. However, if the discrepancy is very large, for example, 50 kilodalton in expected value, 150 kilodalton in experimental value, so this is not acceptable and should be avoided in our analysis. Okay, so far any question? We have finished this chapter.
So far, okay, Doctor.
Okay, Doctor.
Okay, if so, we continue with lab activity number 1. Five protein sequences here. So everyone need to try to analyze these protein sequences using bioinformatic tools. As shown in the file I shared in our group, there are 5 protein sequences, and I did not put any names so that we at the beginning we do not know the function or the origin of this protein. So by using bioinformatic tools, especially in the practical one, practical one, where are you? Okay, so practical one is about protein sequence analysis. If you want to get some guidance, you can refer to this YouTube link provided in this manual. So the purpose of this activity is to explore publicly available protein database and to use these databases to identify unknown proteins and compute the physicochemical properties of the protein sequences. So for particular one, you need to use the available tools first to identify unknown protein sequence which has been given in the file I shared in our group. Then you need to compute the physicochemical properties such as amino acid composition, molecular mass, pH value, and others by using different tools. To identify unknown protein sequence, you can use BLASP program. To compute physicochemical properties, you can use param bioinformatic tools. Both are available in the SPC server, but if you want to use the tools from different sources, you can simply type their name in the Google search engine and you will be linked to the tool so that you can perform the analysis. And of course, before doing this analysis, BLASP and param analysis, you need to know how to retrieve protein sequences. Okay, usually in UniProt KB database, we type the protein names, and you will see list of proteins in either Swiss spot panel or Tremble panel. Swiss spot for reviewed protein sequences, Tremble for unreviewed protein sequences. So you need to decide which one to be used. Then you can download the protein sequence of interest in FASTA format. Okay, then using the same set of unknown protein sequences, you need to learn how to perform 3D protein 3D prediction of protein structure. Okay, so the objective of this lab activity is to understand how we can develop 3D protein structure using bioinformatic tools. We are not going to use a more advanced tool like AlphaFold, as I mentioned just now, because we want to learn the basic. We want to learn the earlier information or knowledge. Then we can understand the more advanced bioinformatic tools. So you need to access Swiss model tool either in SPC server, or you can simply type Swiss model in Google search engine and you can start the modeling process. Just follow the step shown in this manual and you will see your result. You can download your protein models. You can also evaluate whether your predicted 3D structure has high quality or low quality. Okay, assessment the quality of your 3D protein model is based on Ramachandran plot. If this Ramachandran plot analysis give you a high percentage, for example, 95% above or 90% above, indicating your 3D model is more accurate and reliable and can be used for other analysis. If your Ramachandran plot analysis show low percentage value, so you need to repeat the prediction process and unique